Next data type is called as an integer data type. In integer data type, we can store a 16-bit information, that is 2 byte. Integer data type has two types. One is called as unsigned integer and the second one is called as a signed integer. So let us look at the unsigned integer. So if I find out the value 2 raised to 16, we can store about 65,535 values in the integer data type. So when I say it is an unsigned integer, we can store only positive values. In a case of real-time ICs, we require integer data type. So these kind of ICs store the information in the form of hours, minutes, seconds, days, months and the year. This data is of integer type and this data is strictly positive. So very rarely we used integer data type, and that too unsigned integer data type. Integer data type is rarely used because it requires a 2 byte of data storage, whereas 8051 can process only 8 bit at a time. So in a case of 8051, integer data type is very rarely used. In some cases, integer data type is used to generate a large amount of delays. Now let us look at the signed integer data type. In this data type, we can store a positive as well as the negative values. As it is of 16-bit, we can store the value range from minus 32,768 to positive of 32,767. So once again, we can take an example of a temperature in which the temperature ranges from, let us say, from 1000 degrees to 2000 degrees, or maybe in a chillers where the temperature ranges up to minus 500 degrees centigrade. So in such cases, we cannot go with the char data type. In such cases, we have to go with the integer data type only. Similar with the case of an analog waveform which has a positive as well as a negative values which ranges beyond the 255. In such cases, we have to go with the integer data type. Next data type is called as a single bit data type. Its keyword is S-bit. So this data type can store a single bit of information. The information like whether the switch is on or off, or whether the LED is on or off. So this data type is always used when you are interfacing any hardware with the external port pins only. Now the next data type is called as a bit. Now this data type also stores a single bit of information, but it stores this single bit of information within 8051. It stores the information within a bit addressable area which ranges from 20H to 2FH. Now here we have to remember that we are using an S-bit and a bit data type to store a single bit of information, but S-bit is always used when we are dealing with the port interfacing, whereas we are using a bit data type when we want to store the information within a microcontroller within the bit addressable memory area only. The S-bit is used while interfacing with the port, and the bit data type is used only when you are storing the information within the microcontroller. Now the next data type is called as SFR. So SFR stands for special function registers. So this special function register data type is used to address the ports, different kind of ports, or the different kind of registers within the 8051. So by using this SFR, either we can call these registers by their name or either we can call by their addresses. Now in the example I have shown how this data type can be used. So it has a prefix called as SFR, and after that we have to suggest the name, that is P1, and we have to mention its address in a hexadecimal, so that is P1 is equal to 0x80. As you know that this is the address of an port 1. This data type is very rarely used because all the addresses are already mentioned in the header file. Now let us look at the summary of the different data types that are available in an embedded C. So in unsigned char, it can store 8 bit of data and which stores only positive value ranging from 0 to 255. We can have a signed char which also stores an 8 bit of data, but its ranges from minus 128 to plus 127. The next data type is called as unsigned integer. So this can store 16 bit of information. It has only positive range from 0 to 65,535. The next data type is called as signed integer. This is a 16-bit integer data type in which we can store a positive as well as a negative values, which ranges from minus 32,768 to plus 32,767. The next data type is called as S-bit data type, which stores a single bit of information, and as I mentioned that whenever we are interfacing the device to the external ports, this data type is used. The next data type is called as bit data type. This also stores a single bit of information, but this stores the information within the bit addressable area of an 8051. The next data type is called as a special function register, or the SFR. This is also stores an 8-bit information, but this information is actually an address of the particular register. Now let us compare the C program and the embedded C program. Now we have already learned how to write down a C program in a mathematics course. There are some similarities and there are some dissimilarities in a C program as well as in an embedded C program. Most of the syntaxes are very similar, but the header files in embedded C programs are really different. So let us try and compare of an normal C program and embedded C program from the next slide onward. Now let us look at the normal C program. So here I have shown the program which calculates the area of an rectangle. Now the first part that we are going to look at is the program starts with a hash include stdio.h. Now this hash include stdio.h means it gives a command to an compiler that it requires an .h file which name is standard input output, that is stdio.h, should be included before the compilation of the program. Now the next thing that we should focus upon is the main function. So main function starts with void main and void, which means that it doesn't take any value and it doesn't return any value. So the first void, it means that it doesn't return any value, and within the rounded bracket the second void means that it doesn't take any value. So this is the topmost function in any C program. Now if you observe, the next thing is that this main function is written within the open parenthesis and the close parenthesis. So this tells the compiler is that where the program starts and where the program ends. So C program is basically is a collection of different kind of functions and variables, and this parenthesis will tell you where all those starts and where the main program ends. So after the main function we have to declare the data types that we are going to use in the program. So here in this case we are going to use two variables. The name of those variables are height and width, and those are of integer type. So it should be followed by int, and that is a keyword, and it should be followed by the variable name, that is height and width. After each statement we have to put the semicolon so that the compiler knows that here the statement ends. Now let us compare a normal C program and embedded C program. As I told you, all these program begins with a hash include. So it is also called as a preprocessor compiler directives. So it tells the compiler what kind of files it should include. In the case of normal program, it is stdio.h, which includes the standard input output files for the C program, whereas for embedded C it has a hash include regx51.h, which means that this program is written for 8051 microcontroller. After that you can see that the main function is written in a same manner like void main void, so it doesn't take any value and it doesn't return any value. After that the main function starts with open parenthesis and it ends with a close parenthesis. Within that we are going to use a super loop with the while, and within that we are going to define some of the data types that we are going to use. So here in this case I have mentioned that we are going to use unsigned char z. As I told you, 8051 is an 8-bit microcontroller, so the most of the time we are going to use a character data type. Either it is a signed or either it is unsigned char. Now here you can see that the most of the program is very similar to that of a normal C program. So there is only one change, that is the include file. For normal program we are including an stdio.h file, and for embedded C program we are just including regx51.h file. This is the real benefit of using an embedded C program for an 8051 microcontroller. As you can see that the most of the syntax used in a normal C program and the embedded C program is very same. Structure of a normal C program and the embedded C program is very same. We have already discussed that the C program is a portable. Now here is, in this case you can see that This program is developed for 8051 microcontroller. So same program can be developed for any other microcontroller. We have to just change that include file. Right now it is regx51. So if you want to develop the same program, we have to include different header file, but the rest of the programs remains the same. So that is the best benefit of using an embedded C language.